All right, welcome everyone to the HPC Best Practices webinar series. We had a bit of a hiatus for the last couple months, but now we're trying to resume. I would ask any of you who have suggestions for topics or would like to volunteer to give a webinar in the future, please don't hesitate to reach out to me. My email is, I think, readily available from the avenues that you've seen on the subscriptions, but I'll put it in the chat in a minute as well. Today, I'm happy to introduce Bhavesh Patel from the California Medical Innovations Institute, who will be speaking to the topic of making research software fair. We want this webinar to be interactive and we encourage you to ask questions. We'd like you to do that through a Google Doc that we have a link for, and I'll put this link in the chat as well. I will try to transfer questions from the Zoom chat into the Google Doc, but this will give us a chance. So we'll try to ask Bhavesh whatever questions we have time for during the presentation, but we'll also ask him to add some follow-up, especially to anything he doesn't get to during the webinar itself. Also, we would like to get your feedback on this and other webinars that we present. So there's a feedback link, and I'll be putting that in the chat as well. And finally, everybody who's registered for this webinar will receive an email once we get the recording and the Q&A and everything posted. Please feel free to share that with colleagues and also let them know about the webinar series in general. And with that, I'll hand it off to Bhavesh and we'll get started. Thank you.
Hey, thank you so much, David, and hi everyone. Let me share my screen again. And yeah, so I'm Bhavesh. I'm a research professor at the California Medical Innovations Institute. We are a nonprofit biomedical research organization located in San Diego, California. And here I lead this division I started called the FAIR Data Innovations Hub. And I'll throughout the talk, I'll mention what we do specifically in that division. And today my talk will be about 45 minutes with time for questions. And again, David, feel free to stop me if you feel there's a question that I should answer as I'm going through. But I'll also try to kind of keep enough time, hopefully, towards the end to answer as much question as possible. And I'm hoping by the end of this talk, you'll learn why and how to make research software FAIR, where FAIR stands for Findable, Accessible, Interoperable, and Reusable. And to give you some background, we actually started thinking about this around December 2021, so it's been over 3 years. And the way it started is that with my team, the thing we do mostly is develop software that helps make biomedical researchers help them make their data fair. And we think, hey, maybe we should also make our software fair. And so that's how we started thinking around this question about, okay, how to make our research software fair. And I kind of take you through this journey that I took into kind of finding an answer to this question. And kind of spoiler alert, there's still no answer, but there is some kind of portion of answers that are already kind of helping towards that effort. And I think there's two main things in here in this question. One is research software, one is FAIR. So I'll kind of talk through each of them to kind of explain what they are. And I'll start with research software. The kind of in this work, the common we follow this kind of common definition of research software, which is any software creating during the research process or for a research purpose. And so, for instance, if you're using Excel to analyze or visualize your research data, Excel would not be considered a research software. But if you develop a Python script to do the same, that Python script will be considered a research software. And given, you know, how broad this definition is, you can imagine that there are many different types of research software that fits within that definition. And they can come in various formats such as Python script, C++ code, Fortran code, desktop app, web app, and so on. And software can be, research software can be developed for various applications, including data analysis, data visualization, computational modeling, AI and ML model development, and so on. And I think many in this audience would agree that it's an essential element of research. More and more research projects include some sort of development of research software for again, any of the applications I mentioned previously. And now even many research projects are all built around developing a research software. So more and more you see that research software is the main outcome of many research projects. And yet, despite kind of research software being so important, it's not always made reusable. And so typically as part of a research project, there'll be many research outcomes. What we tend to focus on as researchers is really on the knowledge and findings, and we kind of are consistent in publishing those through manuscripts, and they kind of are usually made broadly available, findable to others. But what we don't focus on is other research outcomes that are becoming kind of as important, if not more, which include software, right? When you look at software that are developed as part of a project, most of them are not shared. When you go through a manuscript, there'll be mention of, hey, we use this code or build this code to process this data or analyze this data, but then there'll be no mention of the code. Sometimes it says that, oh, code and other things will be available upon request, and when you email, nobody replies. Sometimes those are shared. Either again, there's a GitHub link into the manuscript, or you can email the authors and they'll be nice enough to send you their code. But what happened even when it's shared, it's often not reusable because there's not enough documentation or information on how to run it, or it's not kind of structured easily well enough, and so on. Sometimes it becomes reusable after what we call curation, which is, okay, you kind of trying to figure out, or again, having more back and forth with the authors. And very, very rarely it happens that, hey, you can easily find a research software and readily reuse it because it's well documented, well structured, and so on. And this is kind of critical to do for many reasons. You can imagine why sharing and making research software reusable is essential, and I'm listing kind of a few reasons here. It would enable reproducible, transparent research. So for instance, if I have some code that I have used to kind of process my data and format it and so on, only if I make that code available will other be able to reproduce my results and go through the same process. It can also prevent duplicate effort. And you can imagine that at a given time, there's likely many people working around a similar problem or project. And if you make your code available, it would help other either reuse it or at the very least kind of use it to jumpstart their own effort. And also, it could be useful to the person developing research software to get recognition. Very often, software is not really considered yet kind of a first-class citizen of research, but if we make it available, other reusing it, mentioning it, and so on, could help get recognition for that critical effort as well. And so then the question that we had again, after going through the same realization that we should make our software that we build reusable was, okay, how to make research software reusable? What does it mean? Are there some guidelines or other things that are readily available that says, hey, if you do this, it would be enough to consider your software reusable? And the first thing we looked at were the FAIR principles, because we were working around the FAIR principles to make data reusable. And at the origin, the FAIR principles were developed around this one question, which is how to make all research outcomes, including software, actually, although they are focused, their use is currently focused on data. They were originally developed for all research outcome, including software. And so how to make all of that optimally reusable by humans and machines. The idea with including machine in this question was that more often than not these days, reuse of research outcome, again, heavily data is all for AI and ML development, so it's used by machines. And so a lot of people got together from all around the world, from all field of research, including researchers, funders, scientific publishers, and so on, to kind of try to answer that question. And their outcome was published in 2016 as the Findable, Accessible, Interoperable, and Reusable, or FAIR Principles. And so those are a set of 15 principles that everyone should aspire to follow to make their research outcome optimally reusable, again, by humans and machines. And they include things such as data are assigned a globally unique and persistent identifier, data described with rich metadata, and so on. And they have been, since their publication, very widely and broadly adopted around the world, again, in all fields of research, be it at the kind of G20 level, the European Union level, or at funding agencies level, such as the NIH, particularly in my field, since I'm in biomedical research. And they're not only kind of supported, but almost enforced. And for instance, for us who are writing grants to the National Institute of Health, since 2023, we have to include with our proposal something called a data management and sharing plan, where we describe how data that will be collected from this project will be made fair if the project is end up getting funded. And so we thought, hey, great, this is exactly what kind of we should do, is take these FAIR principles and find out how we know how to apply them in data, because that's what we have been doing. Maybe let's find out how we can apply them to our software and kind of be done with that. And we did find some guidelines that were kind of, hey, how to implement these FAIR principles to software. But what we mostly found was that many in the research software community found that the FAIR principle were not suitable for software. And so although they claimed that they were for all research outcome, when you read them and when I kind of went over a few, you saw that they were written about data. Data is assigned a unique identifier. And again, even through the development, it seemed to many in the research software community that they were written keeping data in mind and not necessarily software, because it didn't take into account for the granularity of the software. So they didn't take into account some of the many major differences between data and software, including granularity, meaning that, okay, a software has like a code file. It comes as a package software, you have the deployed version, and so on. It didn't take into account the dependencies, contrary to data, which kind of exists as a standalone and can be used as a standalone component. Software would have dependencies on many other software usually. And software also come as multiple versions, when data would be one version, maybe two at most. Software have continuously new versions coming out. And so those people who were not, again, satisfied with the original FAIR principle got together, started something called the FAIR for Research Software Working Group, or FAIR4RS Working Group. Involved, again, similarly to the FAIR principles, this involved a lot of people from all around the world, worked on it for 2-3 years to adapt these principles for software, and they published in 2022 what they call the FAIR principle for research software, or FAIR4RS Principles. And so this is what they look like. They have 17 principles, again, with the same idea that these are principles anyone developing a research software should aspire to follow to make it optimally reusable. And when you look at them, you can see that many of them are similar to the original principle, with just the word software swapped in for data. But there are also a few that are novel, including having a unique identifier for each version, and few more. And few have been actually removed that were not deemed relevant for software. And when you look at them at first, they can be a little difficult to understand what they're trying to do, but maybe an easier interpretation is as follow. And again, it kind of mimics what was the thought process for the original FAIR principles for data. But here, the idea is that for a software to be optimally reusable, first it needs to be found. And so the principle under the findable category specify things like software needs to have a unique identifier, which makes it easy to identify and find, and should have metadata that's indexed in search engines. meaning that if someone is searching for your software, let's say on Google, or for some keywords related to it, it should kind of show up. Then once the software is found, it needs to be accessible. And accessible here doesn't mean accessible to everyone. It just means that the access process is clear. And so the principles under accessible specify that the software is accessible using a standard protocol, so using things that people are used to, such as over the internet, and that the access requirements are clearly stated. So who can access it, how, under what condition, and so on. And then once the software is accessed, there's two characteristics that are kind of prescribed by these principles. First is for the software to be interoperable, meaning it interoperates with other software. So it means that the software reads, writes, and exchange data following applicable standards, so you can use it in kind of uh, uh, with other software that are kind of related, and also that the connections to related resources are documented, meaning that if some data or other things are needed to run your software, those should be documented explicitly. And finally is for the software to be easy to use. And for that, it should have a clear usage license, and also it should be well documented so anyone can easily understand and reuse the software, and also know what are the usage conditions once they have accessed it. And when you think about it, this kind of seems very basic, like, oh, okay, that seems like something we should all be doing. We have been doing this for years for manuscripts when we think about it. All manuscripts have a DOI as a unique identifier. When you publish a manuscript, the journals make sure they get indexed. So someone searching for the manuscript on Google Scholar, in our case in PubMed, for instance, the manuscript kind of shows up. The journal kind of handles the access process. So you can go on the journal's website and know, hey, is it open access? Do I need to log in? Do I need to pay? And so on. We all follow PDF format for the manuscript. They mostly all have the same section with abstract, introduction, method, and so on. And they all also have a license when you look on the journal. We don't really tend to do that, but there's typically a license that's specified that says, hey, how you can reuse it, and so on. But I think it needed to be said for data, which the original FAIR principles achieve. And again, it needed to be said for software. This is what the FAIR4RS principle achieved. And so we thought, hey, great, this is exactly what we were looking for. And so let's just apply the FAIR4RS principles to our software and kind of be done with this. But again, it was not as simple, because the FAIR4RS principle, just like the original principle, by design being principle, they do not provide actionable instructions. And so we had questions such as, okay, what unique identifier should we use for a software? How do we get one? What does it mean to have rich metadata, and where do we provide it, how, and so on? And this was kind of particularly overwhelming for people like me, where I don't have a background in software development. We're developing software just because we need it as part of our research project, and that's kind of, I think, a very big portion of people developing software, at least in biomedical research. And so we were kind of struggling to find such answers. And so then me and a few colleagues thought, okay, maybe let's do a kind of proper research into how we do all of those things, and maybe we can put out some guidelines that other can use too, so they don't have to go through the same process. And that's how me and a few colleagues in the biomedical field developed something we call the FAIR Biomedical Research Software, or FAIR-BioRS guidelines. And so those are a set of minimal actionable step-by-step guidelines, so that if you follow them, you will kind of comply with each of the 17 FAIR4RS principles. And like I said, we started on this around December 2021, and we were kind of done in August 2023. So over a year and a half later, when we published the related manuscript to these guidelines. And so again, what was supposed to be just a little, hey, let's see how we can make software fair, turned out to be a much longer side project. And again, it took a long time, because It was only a few of us. It was not like a funded project. So it was just us doing it a little bit more because, hey, we were like, oh, let's just have some guidelines so we don't have to think about this. And so kind of it went a little bit slow, and we also kind of make sure to present it at a few conferences, including at the Informatic Open Source Conference, to get enough feedback and inputs from our community, at least before we publish them. And here's a snapshot of the guidelines. And again, you can find the full guidelines in our manuscript, but they're structured such that there's a few things that's specified to do before you start developing your software, things to do while you are developing the software, and things to do as you're releasing a new version. And I won't go into details through them for now, but I'll talk a little bit more about them towards the end. But again, we thought, okay, now the job is done. We have some guidelines. We also made them available for others. Let's just kind of apply them to our software and move on with our life. But then as I presented these guidelines and talk about them with people outside of biomedical research, including last year at the US Research Software Engineering Conference, some of the comment we had was that, hey, most of the things you mentioned in those guidelines are not bio-specific that could apply to anything, right? Again, I think I had in my guidelines things like work from a version control platform, have a license, have a README, have a citation. Those are not really necessarily bio-specific. And so they were kind of telling us, hey, why didn't you just say these are for any software? And my response was that we were not really comfortable because all of the authors of the FAIR-BioRS guidelines was from the bio field. The conference or the community we consulted were also from the bio field. And so we did not feel it would be appropriate for us to say, hey, we have guidelines that anyone can use to make their software fair, where they did not have kind of external inputs. And so one of the suggestions I got at that conference was to maybe start a task force to have other people from other community involved. And again, I thought, hey, this would be a good idea if rather than having guidelines for each field, we could have some general guidelines that anyone can follow to make their softwares fair. And specifically because with software, there's a lot of interdisciplinary connection, right? You don't just develop software and use things that are only bio-specific and so on. So I thought it would be actually very valuable if we had some domain agnostic general guidelines rather than field specific. And so I took up on that advice and started something called the Actionable FAIR4RS Task Force. And so this is a task force that we started last year under the Research Software Alliance. And so again, I submitted, I think, a proposal around August, it was like, or September, and it was accepted the month after, and we had our kickoff meeting in December 2024, so maybe what, 5-6 months ago. And as I mentioned, the goal of the task force is to establish actionable guidelines to make any research software fair in line with the FAIR4RS principles. And some of the new challenges we're dealing with or kind of trying to kind of tackle compared to the FAIR-BioRS effort. One is how to develop domain agnostic guidelines, right? Because there is sometimes different requirement from different field of research, be it because of the funder or the nature of the software and so on. Also, the FAIR-BioRS guidelines were really kept developed thinking about open source software, although the FAIR4RS principles, if you look at them, do not require software to be open. It just says to make it findable, accessible to your target audience, and whoever is your target audience is up to the developer of the software. So you could make closed source software, commercial software and whatnot fair as well. And so here we're trying to address this question about how to have guidelines that works both for open but also closed source software. And also we're also thinking about how to keep up with evolving standards, right? Because contrary to principles, guidelines are really prone to fast changes, right? Because let's say we suggest to using a platform like Zenodo to get the DOI, but what if it's not kind of running anymore tomorrow. So we'd have to update the guidelines with something else. What if the field decide or the standard change and the old one are kind of not there anymore? So we have to keep updating the guidelines. And so that's another thing we're trying to think is how do we keep this going and not just publish some guidelines and kind of disappear and then let people deal with things they find in the guidelines that are not active or relevant anymore. And so we have currently about 12 active members from different geographical location and various research domains. But we could still use more help. And so if you're interested in joining this task force, please email me. We are having a blast. And the first cool thing we did is try to interpret the FAIR4RS principles. And so what we did is looked at the work of the FAIR-BioRS guidelines, the original publication around the FAIR4RS principles, and kind of tried to understand each of the 17 principles, what they mean, what they require, and what are the questions we had kind of to implement them. And we identify about 6 categories that we would have to think about to establish actionable guidelines to fulfilling those 17 principles. The first one is identifier, where we have questions like, hey, what identifier to use for open, for closed software, how to get such identifiers, and so on. The other one is metadata for software publication and discovery. So what metadata do we need for publication or discovery of software? How do we provide it, and so on? Sorry. Standard input-output. So one of the principles is for the software to read, write, and exchange the information in a standard way. So what are those standards? Which one can we recommend as part of the guidelines? How do they differ across either field of research or programming language, and so on? Qualified references, there's a couple of principles that says there should be qualified reference to other software and to other resources. And qualified references here means references that are well defined. So meaning that this software needs this data to run. This software is dependent on this other software. So meaning having a qualified relation between the software and the other resources rather than just listing a bunch of references without mentioning what they're needed for. Metadata for software reuse. So similarly to discovery, there's some metadata that are mentioned that needed for reuse. And so the question is, what is the metadata needed for reuse? How much documentation is necessary for different software, and so on? And the final one is licenses. Again, how we provide some guidelines to people like me who don't have any background in software development, and license was one when at the initial stage when I got into developing code and so on that I struggle with. So can we provide some guidelines or resources in our guidelines that help people choosing the right license and providing it into the right format and so on for their software? And as you can see, so there's many questions associated with each of these categories. So what we are doing now is splitting up into 6 subgroups. So there's 2-3 people into each of the subgroup, and they're tackling the related questions through literature review, looking into past work or related work, maybe reaching out to certain communities that are already addressing some of those questions to kind of gather some answers. And so we are hoping in July, so in a couple of months, each subgroup will come back with their answers, and then we'll work on compiling them into some guidelines that anyone can follow easily for making their software fair. And we are hoping around September, we'll release a first draft and then publish them in January. And then start thinking about, okay, how do we maintain these guidelines? Like I mentioned, they're prone to change. How do we kind of keep up with those changes? And we have a page on the Research Software Alliance website here where we can learn a little bit more. We're trying to keep it up to date so we kind of add our progress and so on up there. And again, there's also information if you're interested in joining. And so then again, we started this in December 2021, did some work, but that's kind of, again, after over 3 years, this is still ongoing. We have this task force that's trying to establish guidelines that anybody can follow. And so the question is, okay, how do you make your research software fair today? And I think you can, although we are kind of working on specific guidelines, there's already a few simple steps that you can do that would cover most of the requirement of making software fair. And that's where I kind of go back to the snapshot I had from the FAIR-BioRS guidelines. Even though we are still working on the task force to establishing these guidelines, again, I believe that many of the things we had in the FAIR-BioRS guidelines are still valid, still kind of relevant, and again, things that you can already do while there is better guidelines or more generalizable guidelines that come. And so again, things that you can do today is before starting developing your software, kind of choose a version control system like GitHub. Why? Because it helps kind of make your software findable. That's where mostly people will go look for a research software. It handles kind of making the software accessible over the internet. It also helps with reusability. Typically, you would have some kind of documentation up there to your README, or at the very least, it takes kind of has a good history of what happened to the software. So one of the principles is about having detailed provenance about who developed the software, what people contributed to, and GitHub with their kind of version control history would help with that. Then before starting, you want to select the license and including in a license file. Again, it's because the dependencies of your software will be dependent on what license you use. So that's why it's important to have it selected before you start developing. And again, there's a principle under the reusable category that explicitly said that each research software should have a clear and accessible usage license. So that's what you'll comply with if you have a license file. Then while you are developing the software, you can make sure to record your dependencies. And again, we don't have very specific guidelines here, but we do mention in the FAIR-BioRS guidelines some example, like, okay, have a requirements file if you're developing a Python code, and we have some specification for different languages, but it would help with making the software interoperable and reusable. Then maintaining a README, again, having a nice documentation. And again, in the FAIR-BioRS guidelines, we do provide some more specific instructions on what information should be included in the README to comply with the FAIR principles. And then when you're releasing, each time you're releasing a new version of the software, what you want to do is include or update certain metadata file like a code meta.json, citation.cff, and the changelog. Those would help with making your software findable. Again, the code meta and citation have different information about who are the authors of the software, what is the license, who funded, and different information. And it would help again with making it findable, but also reusable through more provenance metadata. And then archiving each version on a DOI issuing repository like Zenodo. Again, getting a DOI for each version would satisfy some of the principles that require a unique identifier under the findable category. It would also, again, having it on Zenodo, make it available more through the Zenodo search feature. Index it using some standard schema.org format metadata and make it accessible through Zenodo. So those are some steps that, again, you may be already taking them. Some of them are very standard practice. Maybe some of them are not so much, like the code meta, Zenodo archival, and so on was a little new to me. That could help comply with more and more of the FAIR 17 FAIR principle, if not all yet. And even this simple step could still be time consuming. For instance, what I kind of personally was finding annoying with my own guidelines was that with each software release, you have to update the release date, the version number, the authors at multiple places, including in those metadata file, but also when I archive it on Zenodo, I have to update that information. And so what we are doing with my team is developing something we call Codefair, which is an open source and free GitHub app that kind of acts as your personal assistant for making software fair. And the way it works is once you install the app from the GitHub marketplace on the GitHub repository of your choice, you can then code and develop the software as usual. When it's installed, Codefair opens a GitHub issue and update it with each new commit to your main branch. where the GitHub issue would list how you are complying or not with the requirement of the FAIR principle, and where you're not complying, there'll be a button that takes you to the Codefair website where you can understand what the issue is and even address it directly from the website, submit a pull request from it to fix it, and then the issue will update and say, okay, now you're complying with this requirement. And for those of you who are not really familiar with the GitHub app, when you install a GitHub app on a repo, it's very similar to giving permission to a new user to your repo. And then this user will do whatever permission they have and whatever their kind of task is. And in the case of Codefair, it acts as a user who monitors your repository to see if there is how you're complying or not with the FAIR principles, and also submit pull requests to help you address any compliance issues. And so I think this is a little complicated, but I'll try to do maybe hopefully a good job at explaining. But when you install the Codefair app on your GitHub repo, what it does, the GitHub app, it kind of monitors and listens to what's happening every time you commit to the main branch, scan to your code files and so on, and updates the Codefair GitHub issue to see if there's things that have changed that have either you comply now with some of the requirement. Let's say you have a license file, or you're missing a license file, do you have a code meta file or not, and so on. Is it in the right format or not? And then we'll update the GitHub issue every time you submit a commit to the main branch. And you as a user, you can look at this GitHub issue, learn about what you are doing right or not. And if there's something that you don't comply with, there's typically a button that takes you to the Codefair web app where you can learn more and do a few things as instructed to kind of directly from the website to address the issue, maybe provide more information, maybe select a license or whatnot through the web app, and then save it to that. The web app will tell the GitHub app to submit a pull request, let's say to add a license file or to add a code meta file and so on, and then the issue will update again and so on. And so maybe to provide again a little bit more concrete example, here is the GitHub issue that's opened when you install the Codefair app. And again, it lists a few things that are required to make your software fair. If it's found, there's really a little a check mark. If it's not, for instance, in this repository, there is no citation or code meta file, will tell you, hey, that's needed to make your software fair. And there'll be a little button, let's say in this case, that says add metadata. When you click on it, it takes you to the Codefair website, where it explains you a little bit more why these files are required. And in this case, rather than having you create the citation CFF and code meta.json file, which will require you to understand their specific schema, language they use, and whatnot, what Codefair provides is a kind of a nice form where you can provide the different information required by this to metadata file. And once you are done, you can click on this Save and Push to Repository button. And again, then the web app will grab all the info from this form and work with the GitHub app to submit a pull request to your repository. And when you merge that pull request, you'll see that your repository now will have a code meta and citation file in the right format, and this kind of requirement will be check marked as well. And currently we have a few features only. Again, we are developing that on the side. So we have support for license check, metadata files check, and also easy archival on Zenodo with each new release, where all the release date, the version number are updated automatically for you at the different locations. So all you have to do is kind of click on the release button and go through a few steps to make a GitHub release, but also a Zenodo release with all the right steps automatically taken care of. And we're in the process of kind of adding more features, such as having help to create a README or improve your README, having code formatting, and so on done. And again, here we are not kind of necessarily reinventing anything. If there are tools that help with any of those things, we will integrate them. And so, for instance, for the citation and code meta, there's validator that exists. So that's what we use to validate those files and see if there is any error, we show you through the GitHub error message. So the idea is really that once you install this, you can kind of forget about any FAIR requirement, work with your thing, and Codefair kind of integrate with different tools that exist or add a few new ones to kind of tell you through the GitHub issue, hey, should maybe do this, and then you can go on the website to fix it quickly and then get back to developing your software. And you can imagine that this idea about a GitHub issue and web app that kind of helps you keep your software fair could also be applied beyond fair. So we're thinking about adding some feature related to software quality, security, and so on. Again, that I think would be very useful to people like me who don't have a software development background or may not be familiar with those requirements, and also to all the different tools that exist to already help with to kind of just have a central location to say, okay, I install Codefair and tell me everything through the GitHub issue and help me out. And we would really appreciate it if you can try it. Let us know what you think. Again, this is free open source. We don't have funding. We do get a little support from Microsoft in terms through Azure credits, and so that's what helping us kind of keep it running for now. And we're again thinking about applying for some grants if we see that there's interest from people beyond just us who are interested in using this to making their software fair. And some closing comments. I think today I tried to cover that research software is an essential element of research, and making it fair is critical. The FAIR4RS principles are there to kind of provide a high-level framework on what to do to make software reusable, but they only provide high-level instructions. But we have this actionable FAIR4RS task force that is working hard to develop minimal and actionable guidelines to make any research software fair. And you can all support us kind of by joining the task force and maybe trying out Codefair and letting us know what you think. And with that, I'd like to thank everyone who was involved in the different work that I mentioned, the FAIR-BioRS guidelines, the actionable FAIR4RS task force. Thank the organizer for inviting me today, and of course, thank all of you for listening. Thank you.
Thanks very much, Bhavesh, for a great talk. I think it's really important that we all work to make our software as well as our data more fair, more accessible. I'll mention a couple of things here. First of all, next month's webinar, which we've started announcing, is going to be on software citation. So it's closely related, but a little bit different, and also a very important consideration for making sure our software gets recognized. So if you haven't seen an announcement for that, feel free to reach out to me. The second thing is Bhavesh's slides had a number of links that you may be interested in. Those slides are posted on the event page, and you'll get, when we add the recording and the Q&A, you'll get an email with the location of all that stuff. So you can check out those things. And we do have a few questions. If you have questions for Bhavesh, please put them in the Google Doc that I've been linking to. And if you're on your way out, please consider leaving us some comments in the survey, which I've just posted in the chat. So the first question we have here, Bhavesh, is, can you talk more about how your group interprets accessible for closed source software?
Yeah, so I think I wouldn't say it's my group's interpretation, but it's the interpretation in the FAIR principle. I think I mentioned it if I go to one of my slides where I said interpretation is really the access process should be clear. That's what the principle recommends. So it should be clear who should access it, how, and so on. It doesn't mean accessible in the terms of it should be accessible to anyone. It's up to you to decide who is the target audience who should have access to it and make sure it's findable and accessible for that target audience. It could be kind of your, sorry, I'm just going to say, it could be your lab mates, it could be within your company, or it could be, again, if it's an open source to the public.
And there's not a built-in assumption when you say accessible that the source code is necessarily per se accessible.
No, not really. If you look at the principles that are in there, it just says that it should be using a standardized communication protocol. And the protocol itself should be open and free, like again, going through it over the internet, and that it should allow for authentication, authorization, and whatever is required, payment when necessary. And then only the metadata is needs to be accessible. So on the landing page where your software is accessible, at the very least, it should have a little description of what it is, even though the software itself requires like payment or like login or whatnot to access it. So there should be some description of what it is, so people at least know this exists.
Okay, thanks. I think that's useful because many of us, at least in my own mind, I think many of us equate accessible with open source. So that's good to know. Next question. Does the Codefair automation update the citation CFF after a DOI has already been created based on a GitHub tag? Is there any way to update citations and incorporate it into a tag, or do I always have to do that after?
I'm not sure what you mean by GitHub tag, but what we do is that when you create a release through Codefair, we create a draft release on Zenodo so we can obtain a DOI, then add them into the citation file, into the code meta file, and then create a GitHub release and then put that release into the draft Zenodo release and then release the draft Zenodo release officially. And so that way your DOI for this current release will get included into those metadata file. And that's one thing. There is a way, I think there's a webhook where developed by Zenodo and GitHub where you could automatically archive your GitHub release into Zenodo. But the limitation of that was that you cannot get the DOI beforehand. And we reached out to Zenodo to say, hey, can you fix that or improve that? Because we would want the DOI to be included or available beforehand so that we could keep them into our metadata file. Because I think there's one of the principles says that uh, the metadata include identifier of the software they describe, and it was not possible to the webhook. So we tried to address that with Codefair, where we create only a draft release first, get the DOI included into the right place in your metadata file, and then actually make the release, if that's what you were asking.
So the person who asked that may want to turn on their mic and amend or ask further about this.
Yeah, I mean, yeah, this is entirely new draft releases. I thought releases were tags, period.
Don't confuse Zenodo with GitHub. There's two different things going on here.
No, I mean, how can you create a draft release that's not based on a tag?
Oh, okay. I think I know what you mean. Okay, so there's two things, the GitHub release and the Zenodo release, right? So
Sure.
what we do is we go on Zenodo first to get a DOI for the upcoming release, then put this in DOI into your GitHub file, then create a GitHub release, and then put that release into your Zenodo
But
archival.
that means modifying the software that's already, archived. What if, we have
Yeah.
to have, checksums and
Mhm.
things. And so if that doesn't match, your software is corrupted by definition.
So I think this would be the last step. The only thing we'd modify is the metadata file. So you're saying even that should not be touched.
Well,
But so
if you cryptographically sign a tag,
yeah.
it can never be modified.
Yeah, so I think then I think this is maybe where in a use case maybe would not work. The other way, what we are doing is making that available to next we want to do is I didn't mention through API. So maybe you can have your own workflow where you do kind of certain modified version of that workflow if you have other requirements. So you can use the API for the Zenodo archival and so on, but not use it to kind of, again, get the draft release. Or maybe you can have the draft release to get the DOI, include it into your metadata file, then do your checksum and whatnot, then create a GitHub release, then archive it on Zenodo. So maybe there's an extra step for you that comes in that workflow.
Okay. Well, thank you.
Yeah.
Sounds like it might be worth people with special use cases, we'll say, or more complicated use cases that they might want to reach out to the working group and see if they can engage on some of these questions, or with the Codefair app.
Yeah, if you open an issue, that would be great. So I can talk more about the developers for sure.
Great. Next question. You mentioned the importance of updating the README file. What content do you think should be included in the README file?
Yeah, so I think if we go to the FAIR-BioRS guidelines, we mentioned a few things that came up through when we were doing literature review back then a couple of years ago, which was again describing the dependencies or the high-level dependencies of the software, describing the inputs and outputs, mentioning how to cite the software in the README, and a few other things. I think if you go to the FAIR-BioRS guidelines paper, you should see a more detailed information. But I think those are the few things we mentioned that you should at least try to have in there to comply with the FAIR principles.
All right, very good. And one more question. The FAIR principles for research software don't mention documentation to address reusability. At least I don't see a principle related to documentation. This seems to be an omission to me. Is there anything about documentation in the FAIR-BioRS?
Yes, we do mention having a README in the FAIR-BioRS guidelines, or something else like on the read the docs for more complex software that requires a bit more description. I wouldn't say it's an kind of omitted in the FAIR4RS principles. There's a few things they mention about kind of through the metadata, because documentation kind of falls under metadata. That's kind of additional things that you have to help with the software. And so kind of having metadata that's kind of contains detailed provenance would go into your documentation, right? Who are the authors, how you can cite it, who funded it, and so on. I think then there's one catch-all, which is R3, which is software meets domain-relevant community standards. So that's really the one that says, okay, whatever else is required. And I think documentation would fall also partly into that principle R3. And that's why we do kind of mention them as part of the FAIR-BioRS guidelines to have a README, and also additional documentation for more complex software.
Very good. Any additional questions from folks? We've run out of questions people have put in the Google Doc. Any last questions?
David?
Yes.
I posed the last question, and I actually have a follow-up, because I didn't mean the metadata. I meant like if you want to reuse software, you document the interface for the software, like a little more detailed, lower level than what you're describing, but like an application program interface. Are there any guidelines about that?
Not explicitly in the FAIR4RS principle or in the FAIR-BioRS guidelines. Again, we aimed in the FAIR-BioRS guidelines, like I call them, that's why I call them minimal, is really kind of the bare minimum to kind of comply with the FAIR4RS principle. There's no really kind of being perfectly fair. There's kind of a range because they are principle, and you can always have, I think, a little bit more documentation, more specific things. And this is, again, an interesting question for the task force, is how do we address like more specific things, right? Like API, but still keep some guidelines. So these are the kind of things we are thinking about is, hey, can we even have general guidelines, or do we have to branch up about, hey, for a Python package, this is what you need to do. For Jupyter Notebook, if you have APIs, this is what you need to do.
Well,
and those are, yeah, interesting things we're kind of trying to think about.
I don't mean that level of detail. I think it's a guiding principle for reusability. You need documentation
Yeah,
of the interface. I mean, you could just say that,
I
but
see.
I don't know how someone's going to reuse a library without knowing the interface to that library
I
or
see.
software. So it feels like I must be misunderstanding because it feels like a big omission to me, not from your work, like from the starting point.
From the FAIR4RS principles?
Yeah, I hadn't really
Okay.
looked at them before in detail. I knew they existed, but I hadn't read through them. And I'm really interested in reusability, and I just felt like it stopped short of like an R4 document the interface.
I think that makes sense. And actually, they had actually it's closed now, but they had a 3-year follow-up survey, or 3 years. And let's see, I think maybe they might update them based on community feedback. And you're right, even in the original principle, documentation is one that I felt is not, but I kind of think of it as, and that's what I mention it here when I do interpretation. I see software is well documented. I do try to mention it the same way I do for data, but it is not there explicitly for sure. Yeah.
Yeah. Thank you very much. Thank you for your talk.
Of course.
We had one more interesting question come in, which is FAIR optional? Is there any real consequence if it's not practiced?
Oh, good question. I think, again, depend if it's not required by your funding source, I think it wouldn't be anything. It's probably optional. It's just really basic if you think about them again, practices that you should aspire to do, just like we do with manuscripts. If we were not having DOIs for manuscript, if they were not all in PDF, well-structured format, and again, if there were no easy way or consistent way to find them through Google Scholar and other things, you would imagine that maybe scientific progress would be a little bit harder or slower at the very least. And I think it's the same idea. If you can make software fair, it's really to kind of help with making greater, faster scientific progress. It's just part of, I think, hoping that it becomes part of a good scientific practice to just can make software fair. And I think unless, again, there is funding source involved or institutional requirement, it would probably require optional. But the idea, hopefully, is that people see benefit of making software fair. I prefer that approach than I prefer, I guess, the carrot than the stick. Is that, hey, if people see that software are getting cited, if they have all those compliance with FAIR, if they get rewarded, if there's some index that measure, okay, how many FAIR software you have, right? You know, the same way you have H-index, maybe people will be a little bit more encouraged and will see a more incentive to do that. So it would remain optional, but just more encouraged and more, again, incentivized to do so. So it becomes a little bit more common practice is what I imagine for data and software the same.
I'll add to that. In my own experience, I have recently seen calls for proposals where basically as part of the data management plan, they set expectations that your data and software will be fair, and they ask you to address that in the plan, how you intend to do that.
Yeah, that's good to know, because for us, I think I've mostly seen that for data in biomedical research. So it's great to see that it's coming up for software as well.
Beginning to, yeah. All right, we are at the top of the hour, and we've had a good discussion here. I want to thank everybody who has attended, and especially Bhavesh for a great presentation. We'll get this archived hopefully in about the next week, and you'll get an email with the information for the archives. Where to find them, please share with your friends, and look for the announcement for next month's webinar on software citation. Thank you all very much.
Thank you. Bye-bye.